For the last decade, we've all been told the same story. The future belongs to the coders, the software visionaries. But what if that whole story is just wrong now? What if the single biggest opportunity in this entire AI revolution has absolutely nothing to do with code? To get it, you just have to follow the money.
And this is the number that changes everything. $405 billion. That's the insane amount of cash the world's biggest tech companies, we're talking Google, Amazon, Microsoft, the hyperscalers, are expected to spend in 2025 alone. This isn't just some budget bump, it's a bet bigger than the GDP of entire countries. And it tells you everything about where the real value is shifting. For years, this quote was basically the Bible of Silicon Valley, right? Build something light, something with high margins, pure software, and you could rule the world from your keyboard. All the money, all the capital, it flowed to the intangible stuff, the apps, the code that could scale to infinity with almost no physical footprint. Well, that era is officially over. Here's the new reality. There is a massive reallocation of capital happening right now. It's moving away from the weightless world of bits and bytes and into the heavy, dirty, industrial world of concrete, steel, and silicon. The AI gold rush isn't about the cool new app, it's about the gigantic industrial build-out you need just to make the app work.
And this is the part you really have to understand. The algorithms, the LLMs that everyone's obsessed with, they're kind of becoming a commodity. The real competitive advantage, the thing that's actually hard to copy, the true engine of this whole AI economy, is the physical beast you see right here, the industrial scale data center. This is where the physics of AI smacks right into the brute force of capital.
So yeah, everyone's chasing the AI brain. Who's got the smartest model? Who's got the fastest chip? But they're missing the real story. See, there's a hidden absolute bottleneck in this entire system, a physical limit that you can't just throw billions of dollars at to fix overnight. And by the end of this, you're going to know exactly what it is. Okay, first we've got to wrap our heads around the scale of this whole pivot. This isn't some short-term spending spree, it's a total structural reset of the cost of computing. We are entering a brand new industrial phase for tech, and the rules of the game have completely changed. So how does that $405 billion actually get spent? Well, it happens in stages. In the first year, it's a feeding frenzy for GPUs, basically buying every chip Nvidia can make. But look out a little further. The next 1 to 3 years, that's all about building the physical plant, the cooling systems, the power units, the racks. And the long game, stretching out to 7 years, that's all about the grid. The money flows from silicon to steel to the power socket and the wall. The very first physical barrier every single AI company hits is just basic thermodynamics. You can't just run these systems, you have to stop them from literally melting down. The entire industry is slamming headfirst into a thermal wall, and it's kicking off a revolution in cooling. And this just shows you the problem perfectly. On the left, a traditional data center rack. It uses about as much power as a big house. Fine. But on the right, an AI training rack can pull up to 130 kilowatts. I mean, that's an insane amount of power because you have thousands of GPUs all crammed together, generating a ton of waste heat in a tiny little box. Your old data center? It's a fossil. It's obsolete. So how in the world do you solve that? Well, you switch from air to water. Why? Simple physics. Water is 3,000 times more efficient at moving heat than air is. At these crazy new power densities, liquid cooling isn't some fancy, exotic option anymore. It's not an option at all. It's the price you pay to even get in the game. And of course, whenever you have a mandatory tech shift like this, you create a massive economic opportunity. The market for just liquid cooling in data centers is set to explode, going from over $3 billion in 2025 to almost $16 billion in a decade. This is the plumbing of the AI age, and it's where a lot of the smart money is heading. Okay. So cooling the AI brain is one thing, but that's only half the battle. Now you got to connect all the pieces. If the GPUs are the neurons, the network is the nervous system. And right now, that nervous system is hitting a wall, a crisis of physics that means it's the end of the road for copper. It's called the copper wall. See, as you try to send data faster and faster, the electrical signals going through copper wires just fall apart. They turn into noise. And at the speeds you need for AI, this happens after only about a meter. 1 meter. You literally can't connect racks across the data center with copper anymore. It's a hard physical limit. The solution is actually beautiful and kind of revolutionary. You stop trying to shove electrons down a wire, and you start sending photons down a glass fiber. You use light.
And this shift from copper to optical connections is creating another huge supercycle. A supercycle that's growing at a 47% compound annual growth rate. I mean, that's just an explosive expansion happening right now for the little devices that turn electricity into light and back again. The companies that master this tech, the whole field of photonics, they're becoming the new gatekeepers of AI performance. But all of this brings us to the most critical roadblock in the entire ecosystem. We've cooled the chips, we've connected them with light, but none of it, absolutely none of it, matters without this one thing. This is the energy gating factor. It is the ultimate ceiling on how big AI can get. So what is it? What's the final boss of this whole AI build-out? The one problem that even hundreds of billions of dollars can't just solve right away? 8 years. That's the average time it takes to get a new high-voltage connection to the electrical grid in major U.S. markets. Think about that. You can build a billion-dollar data center, fill it with the most advanced chips on the planet, and it will just sit there, dark, useless, for nearly a decade waiting for someone to plug it in. Power availability is the hard cap on scaling AI. Period. And since they can't wait around for the grid, the tech giants are just taking matters into their own hands. They are basically becoming their own utility companies. Amazon is buying data centers right next to nuclear power plants. Microsoft is funding reactor restarts. They're all building their own gas plants on site and installing enormous battery arrays to manage their power. It's wild. So this brings us to the final takeaway. If you want to understand this new era, you have to stop thinking about finding gold and start thinking about building the railroad. Let's look at where the smart money is really going. You know that old saying from the gold rushes, right? The real bottleneck isn't finding the gold. It's the railroad you need to get the gold out. The AI models, sure, they're the gold, but the real lasting value, the companies charging a toll on the road to AI, are the ones building the power grid, the cooling pipes, and the fiber optics. And this matrix just lays it out crystal clear. We're moving from the old way of doing things on the left to the new way on the right. From renting servers in the cloud to owning massive hardware. From air cooling to liquid cooling. From copper wires to optical fiber. And from just plugging into the grid to generating your own power. The winners here? They're the industrial giants, the photonics specialists, and the energy infrastructure players. Look, the ultimate takeaway is this. That whole romantic startup idea of move fast and break things is being replaced by the cold, hard industrial reality of move heavy and build things. The future of AI isn't going to be won in agile software sprints. It's going to be won with decade-long infrastructure projects. Which really just leaves us with one final big question. In this new world where progress is measured in megawatts and gallons of coolant and miles of fiber optic cable, who really holds the power? Is it the person writing the code, or is it the person pouring the concrete and building the power plant? The answer to that, well, that's going to define the next chapter of technology.